There is this very specific, slightly overwhelming feeling you get when a friend hands you a book and they tell you it is the greatest thing they have ever read.
Oh, yeah. The ultimate recommendation.
Right. But then you look down and realize you are holding book 7 of a massive, sprawling, epic fantasy series.
And you haven't read books 1 through 6.
Exactly. You haven't read them. You don't know the lore. You don't know the politics. You don't even know, the magic system. You are just entirely dropped right into the middle of a world that someone else has been living and breathing for years.
It creates a profound sense of disorientation, but also a really unique kind of awe.
Yeah, awe is a good word for it.
Because you are immediately confronted with the sheer weight of the history. I mean, the dedication it takes to build something that expansive is suddenly right there in your hands.
Just staring you in the face.
Right. Before you even turn to page 1 of this particular volume, you realize that an incredible amount of meticulous, quiet labor has happened long before you arrived on the scene.
That feeling of awe mixed with, being completely late to the party is exactly how I felt when we were pulling the sources for today's deep dive.
It really is a deep end to jump into.
It is. We are looking at a single primary source today. It's a personal gardening log entry. It was published on June 17th, 2026, by an author who simply goes by the name Ang.
Just Ang.
Just Ang. But here's the thing that hits you right over the head the second you look at the document. The title of this post is Notes on Gardening, Part 928.
Part 928.
Yeah.
Just let the reality of that number sink in for a second.
It's a huge number.
It is. If you consider the sheer volume of observation, the inevitable failures, the trial, the error, and the meticulous daily record-keeping required to reach entry number 928,
right,
you immediately understand the caliber of the source.
Right. This isn't a weekend hobby anymore.
Exactly. We are not dealing with someone who just casually threw a packet of clearance seeds in the dirt on a sunny Sunday afternoon.
We are stepping into a long-term, deeply committed journey. And our mission today is to extract the hidden wisdom from this specific entry for you.
There is a lot to unpack.
There is. We are looking at an amateur botanist's real-time experiment with a very specific plant called the yellow alder. Scientifically, it's known as Turnera ulmifolia.
Turnera ulmifolia.
We are going to explore how a methodical observation actually leads to genuine mastery. So we are jumping into this epic saga at chapter 928, and we are bringing you along for the ride.
And to really decode what Ang is doing with this yellow alder, we can't just look at the plant itself.
Right.
We have to unpack the underlying methodology being applied in the garden. I mean, this is basically an exercise in applied science happening in a suburban backyard.
Let's look at the initial setup, because Ang didn't just go to the local nursery, buy a single yellow alder, stick it in the ground, and hope for the best.
No, that would be too simple.
Way too simple for entry 928. Ang deliberately obtained exactly 4 distinct specimens of the plant. And then instead of planting them all together in a cluster to make a nice, aesthetically pleasing little yellow bush.
Which is what most people would do.
Right. Instead of doing that, Ang placed each of these 4 specimens at completely different locations, specifically for, in Ang's own words, evaluation purposes.
Ang is essentially mapping out the invisible borders within the garden.
Invisible borders.
Yeah, in horticulture, we talk a lot about microclimates. You might look out your kitchen window and think your backyard is just one uniform environment, but biologically, it's dozens of distinct zones.
Like different temperature zones and stuff.
Exactly. The radiant heat coming off a brick patio creates a localized warming zone. The soil at the bottom of a slight incline might retain water for 3 days longer than the soil at the top.
Oh, wow. I never thought about that.
Yeah, and the wind exposure on the east side of a fence creates entirely different transpiration rates for a leaf than the sheltered west side.
So it's a completely different living experience for the plant just a few feet away.
It really is. By scattering these 4 identical plants, Ang is actively testing all of these subtle environmental variables simultaneously.
Wait, hold on. I see the logic of testing different spots, but okay, let's unpack this. We are talking about 4 individual plants.
We're plants, yes.
In the grand scheme of data collection, is a sample size of 4 really large enough to draw any meaningful, concrete conclusions about where a species grows best? I mean, if I run a survey and ask 4 people on the street a question, I can't exactly publish a statistical paper on the results.
It feels incredibly small.
Yeah.
But this raises an important question about the difference between academic rigor and practical risk mitigation.
Okay, I'm listening.
You are completely right that a sample size of 4 wouldn't get you published in a peer-reviewed scientific journal. However, for a practical home gardener like Ang, 4 distinct data points actually provide a highly effective, real-world baseline.
Really? Just 4?
Yes, because it comes down to parallel testing versus serial testing.
Break that down for me. Parallel versus serial.
Sure. So if you only plant one specimen testing in series and it dies after 3 weeks, you have learned absolutely nothing.
Because you don't know what killed it.
Exactly. Was it the soil drainage? Was it a diseased plant from the nursery? Was it a lack of sunlight? You just don't know.
Right.
So you buy another single plant, put it in a different spot, and wait another 3 weeks. You are losing massive amounts of time.
Oh, I see.
But by deploying 4 plants at once, testing in parallel, you compress your learning timeline. If one dies and 3 thrive, you immediately isolate the variable of that specific failed location.
That makes total sense.
And if all 4 react the exact same way in completely different microclimates, well, then you have identified a universal, non-negotiable trait of the species itself.
That completely reframes it. It's not about statistical perfection. It's about, like, compressing the timeline of discovery to figure out what the plant needs.
Exactly. Speeding up the feedback loop.
But placing those 4 plants in 4 different microclimates is only brilliant if the plant actually reacts to those subtle changes. So did Ang's yellow alders notice the difference?
They absolutely did, and they responded to one variable above all others. The initial returns logged in the entry are overwhelmingly positive for the outdoor placements.
Yeah, so the good news is Ang notes that the outdoor plants are blooming and thriving, and Ang explicitly isolates the primary driver of that success.
The most definitive finding.
Right. Ang writes that provided they have, quote, full sunlight exposure, the yellow alder should thrive without much issue.
Full sun isn't just a suggestion here.
No, it's the mandatory fuel source.
Yeah.
Like, to really understand why the sun is so critical for this specific plant, think about a teenager and their smartphone.
Hey, a teenager.
Yeah. The yellow alder's absolute need for full sunlight is basically a teenager's absolute need for a stable Wi-Fi connection.
That's a great way to put it.
Right. It is the non-negotiable prerequisite for them to function. Like, if a teenager doesn't have Wi-Fi, they don't just quietly do something else. They shut down. They can't communicate. They can't scroll. They can't thrive without issues. Everything stops. For the yellow alder, full sunlight is that stable Wi-Fi connection.
It is the single catalyst driving the biological machinery. And what's fascinating here is how quickly the plant is providing feedback based on that connection.
Yeah. Ang specifically notes that the plants are already blooming.
Which is huge, because in the botanical world, producing a bloom is the ultimate luxury good.
It's an enormous drain on resources, right?
Unbelievably so. It requires a massive expenditure of sugars, water, and complex nutrients just to build a temporary, brightly colored structure meant to attract pollinators.
Just to throw it away later.
Exactly. A plant will simply not authorize that level of energy drain unless its foundational survival needs are being aggressively met.
So the fact that it's blooming means it's super happy.
Yes. The fact that the Turnera ulmifolia is pushing out blooms immediately upon being placed in full sun proves that the solar radiation is the engine driving its most complex biological processes. The intense light provides the surplus energy required to manufacture the luxury good.
But the Wi-Fi connection isn't perfect. As you read further into entry 928, the objective observation continues, and Ang logs the failures just as meticulously as the successes.
Which is the mark of a true scientist. The environmental data is rarely entirely positive.
Yeah, there is some serious friction with this species. Ang points out 2 incredibly frustrating vulnerabilities.
The drawbacks.
Right. First, that beautiful yellow bloom we just talked about, it has a shockingly short lifespan. You do all this work, you map your microclimates, you find the perfect full sun spot, the plant spends all this energy to produce a flower, and then boom, it is over in a flash.
The reward is incredibly fleeting.
It is. And second, Ang notes a distinct troubling susceptibility to pests and diseases. The plant actively attracts bugs.
Which presents a serious logistical hurdle for the cultivator. I mean, you basically have a biological asset that is ringing a dinner bell for the local insect population.
So what does this all mean? Like, I get the appeal of a pretty flower, but with these massive drawbacks. If I have a plant that gives me a super short viewing window, meaning I barely get to enjoy the flowers, and on top of that, it acts like a magnet for microscopic pathogens and hungry bugs, why on earth would a gardener go out of their way to cultivate it?
Why cultivate a plant that just stresses you out?
Yeah. Why dedicate prime yard real estate to it?
Well, It requires looking at the psychology of cultivation through the lens of universal trade-offs.
Universal trade-offs.
Right. The visual reward of the Turnera ulmifolia bloom must be incredibly striking to justify the high-maintenance vigilance required against pests. The fact that Ang is willing to tolerate a highly vulnerable plant with a fleeting lifespan tells us something crucial about its aesthetic value.
It must be a really gorgeous shade of yellow.
It is. But we also have to look at the evolutionary why behind these traits. Like, why does it have a short bloom?
Yeah, why do all that work just to drop the flower a day later?
Because in many hot climates, keeping a delicate flower open and hydrated for days results in massive moisture loss. Dropping the bloom quickly is often a survival mechanism to conserve water once the critical window for pollination has passed.
Oh, wow. So the plant is actually being super efficient, even if it frustrates the gardener who wants to look at it all week?
Exactly. It's prioritizing survival over your landscaping aesthetic.
That makes sense. But what about the pests?
Well, think about what a bloom is designed to do. It produces sweet nectar to attract bees and butterflies, right?
Right.
But that same high-sugar cocktail is incredibly attractive to aphids, mites, and other opportunistic pests. The very mechanism that makes the plant successful at reproducing makes it a target.
So Ang is dealing with a high-performance, temperamental botanical machine.
Precisely.
And because Ang knows exactly how temperamental this machine is, there is no rushing to a final verdict. This is where Ang's discipline really shines.
The patience is remarkable.
It really is. The entry explicitly states, twice actually, that it is, quote, too early to tell.
Which is the smartest thing you can say in gardening.
Right. And this leads us to the most impressive part of the entire document. It's the gardener's ultimate long-term master plan. Ang institutes a strict 3-month maintenance period, a 90-day holding pattern to just evaluate the plants.
The restraint to simply observe and wait is really the dividing line between an amateur who panics at the first sign of a bug and a master who tracks data over time.
Here's where it gets really interesting. I want you to imagine this 3-month evaluation, not like just watching grass grow, but like a 90-day probationary period at a new corporate job.
Oh, I like this analogy.
Right. So the Turnera ulmifolia got hired because it looked great on paper. It blooms in full sun. But you don't just give a new hire the keys to the company on day one.
Definitely not.
You have to run the probationary period. Does the employee actually show up on time? How do they handle a crisis? Can the plant survive the inevitable wave of pests without dying? It has 90 days to prove it can survive the real world.
And if it passes that 3-month mark, it doesn't just get a pat on the back.
No. If it performs well and survives the pests, it gets a promotion. Ang writes that the next step is to, quote, mass produce this species through propagation by cuttings.
It gets to be cloned.
It graduates from an intern to the CEO of the garden.
If we connect this to the bigger picture, what propagation by cuttings actually means is creating exact replicas of the original plant.
Right, but I need you to explain the mechanics of this because I think a lot of people here take a cutting and just, accept it without realizing how wild it actually is.
It is completely wild.
I mean, if I cut off my finger, it doesn't spontaneously grow a new skeleton, a nervous system, and turn into a second version of me.
Faithfully no.
Yeah, so why does a plant leaf or a stem magically know how to build an entirely new, complex root system just because it got snipped off with some gardening shears?
Well, it is entirely alien to how mammalian biology works, which is why it feels like magic. If you cut off your finger, like you said, nothing happens because human cells differentiate early in our development and then they lock into their roles.
Okay.
A bone cell is a bone cell forever. A skin cell is a skin cell forever. But plants possess a remarkable evolutionary adaptation driven by the fact that they cannot run away from danger.
Oh, right, because they're stuck in the ground.
Exactly. If a plant gets partially eaten by a deer or a branch snaps in a storm, it has to be able to rebuild from the wreckage.
It needs a built-in backup system.
Precisely. And this mechanism is called cellular tutipotency.
Cellular tutipotency.
Yes. Many plant cells retain the complete genetic blueprint of the entire organism, and crucially, they retain the ability to kind of forget their current job.
Wait, really? They just forget what they are?
Yeah. When Ang takes a cutting from the yellow alder stem, the trauma of the cut triggers a localized pooling of plant hormones, specifically one called auxin.
Auxin, okay.
This hormone basically tells the cells at the cut site, hey, stop being a stem cell, revert back to a blank slate, and start building roots.
That blows my mind. So the plant is literally reprogramming its own tissues on the fly to survive the amputation.
It builds a new life support system entirely from scratch. And because this is asexual reproduction, no seeds, no mixing of pollen from other plants, the new root system and the resulting plant share 100% identical DNA with the parent.
Wow, so you are creating a perfect biological clone.
Exactly.
Aang isn't just trying to grow a few more yellow flowers. Aang is planning to take the absolute strongest, most sun-adapted, pest-surviving winners of this grueling 90-day trial and build an entire mass-produced army of these specific clones.
It is a phenomenal strategy. You isolate the optimal genetics through rigorous environmental testing, and then you just multiply your success.
It's brilliant. When we first opened Notes on Gardening, part 928, we were looking at what seemed like a simple, maybe even mundane, diary update about a yellow flower.
Just a casual hobbyist's notes.
Right. But beneath that surface, we've unpacked a total masterclass in methodical execution. I mean, we watched a gardener acquire 4 simple test specimens and deploy them strategically to map out the microclimates of a backyard.
We saw the accurate identification of the plant's core requirement, that full Wi-Fi-like sunlight needed to power the expensive process of blooming.
We explored the universal trade-offs behind its vulnerabilities, like the short blooms and the pest attraction.
And we witnessed the discipline required to institute a 90-day probationary period, all building toward a master plan of mass propagation.
It really reveals the deep architecture of what it takes to actually understand an ecosystem rather than just decorate one.
Oh, absolutely.
And there is a real tangible lesson here for you, whether you are trying to cultivate a massive outdoor garden or you are just trying to optimize a workflow at your office or, learn a new skill.
The methodology applies everywhere.
It does. Aang's approach is about risk mitigation. It's the realization that testing in parallel deploying multiple iterations of an idea simultaneously compresses your learning time drastically.
And it teaches us to be patient.
Yes, to resist the urge to declare victory just because something works on day one. True mastery requires you to look at early success, acknowledge it, and then step back and say, it's too early to tell, let's see what the data says in 90 days.
Because early success is merely a single data point. The complete picture only emerges after the system has been properly stressed.
Before we wrap up our dive into entry 928, I want to leave you with one final, slightly provocative thought to mull over, specifically regarding Aang's endgame here.
Oh.
Well, we've spent time praising this brilliant plan to mass-produce the yellow alder through cuttings if it survives the 3-month trial. And we know that propagation by cuttings means cellular totipotency.
Right, it means copying the exact same DNA.
Exactly, creating an army of absolute genetal identicals. Now, combine that scientific reality with Aang's own explicit observation from the log. This plant has a notable, troubling susceptibility to pests and diseases.
Oh, I see where you're going with this.
Right. If you clone a plant to capture its beautiful bloom, you don't just clone its ability to thrive in full sun, you are also cloning its exact genetic weaknesses.
Every single soldier in that mass-produced army will share the exact same vulnerability.
To the exact same pathogens and insects.
It is the inherent risk of creating a monoculture.
So I leave you with this question to explore on your own. If a single yellow alder naturally rings a dinner bell for local bugs, what happens when you have 50 identical clones, completely devoid of genetic diversity, planted in the exact same yard?
It turns a backyard garden into a high-stakes ecological gamble.
Will Aang's meticulous 90-day master plan ultimately yield a beautiful, thriving, golden garden? Or is Aang methodically, deliberately engineering a perfectly designed, mass-produced buffet for every single hungry insect in the neighborhood?
It's a cliffhanger.
It really is. And it makes you realize that when you jump into an epic saga at chapter 928, the story is nowhere near its conclusion. The real drama is actually just beginning. Think about that the next time you test an idea or take a cutting.